Alright, we're going to continue our conversation on polynomials and x-intercepts. And in the last video, we looked at the fact that those x-intercepts were found by setting the factors equal to 0. We also looked at a graph and taking that graph and finding the polynomial. But what happens when we are given just the zeros of the function and we're asked to write a polynomial from that? So the problem we're going to look at today is, given zeros of x equals 2, negative 2, and 3, write a cubic function. Now let me reiterate, this is a cubic function. There are technically lots of right answers here. So the example that we're going to use is, we're going to say that our zeros are x equals 2, x equals negative 2, and x equals 3. Well, what do those x equals, those zeros, give us? Well, they give us factors. So from the zeros we were given in the problem, the factors that we would use would be x minus 2, x plus 2, and x minus 3. You are simply moving those numbers back to the other side of the equal sign. I am subtracting 3 from both sides. I am adding 2 to both sides. I am subtracting 2 from both sides. So if I then want to find the polynomial, I'm going to FOIL 2 of my factors. Now, I have a personal preference. I FOIL the last 2. I think it makes the next step of multiplication easier, but it doesn't mean you have to. I'll leave this factor out here, and I FOIL x plus 2x minus 3. That gives me x squared minus 3x plus 2x is minus x, and then minus 6. I then need to, in order to get this in standard form, multiply this binomial by this trinomial. So multiply x by everything in the second set of parentheses, and I get x cubed minus x squared minus 6x. X times x squared, x times negative x times negative 6. And then multiply negative 2 by everything in the parentheses. Negative 2 times x squared is negative 2x squared. I write them underneath just to make them easier to add together. Negative 2 times negative x is plus 2x. And negative 2 times negative 6 is plus 12. Then I can simply write this in standard form. F of x is equal to x cubed, then minus x squared minus 2x squared is minus 3x squared, and then minus 6x plus 2x is minus 4x, and then plus 12. So there is my polynomial written in standard form for a polynomial, cubic polynomial that has zeros at 2, negative 2, and 3. Let's try another one of these. Let's clear this off. And let's write a quartic polynomial with zeros of negative 2, negative 1, 0, and 2. Alright, so what I have? Well, I have x equals negative 2. I have x equals negative 1. I have x equals 0. And I have x equals 2. So can I come up with factors based upon those? Well, sure I can. If x equals negative 2, add 2 to both sides. My factor is x plus 2. If x equals negative 1, my factor is x plus 1. If x equals 0, my factor is just x. And if x equals 2, my factor is x minus 2. Now, usually the easiest way to change this to standard form is to work with them 2 at a time. So I'm going to take these 2 and FOIL, which is going to give me x squared plus 3x plus 2. And then in this set, I'm going to distribute my x. So that's going to give me x squared minus 2x. And then we're going to come back and multiply all of these together. Well, okay, I like to go from the smallest one to the largest one, but it's up to you. So I'm going to multiply x times everything and then minus 2x times everything. Or you can come back and you can say x squared times these, 3x times these, and 2 times these. Let's just go left to right. So we'll go x squared times x squared is x to the 4th, and x squared times minus 2x is minus 2x cubed. Then I'm going to do the next term. 3x times x squared is plus 3x cubed. 3x times minus 2x is minus 6x squared. 2 times x squared is plus 2x squared. And 2 times negative 2x is minus 4x. So I add my like terms together and I get my polynomial. F of x is equal to x to the 4th plus x cubed minus 4x squared minus 4x. There is my quartic polynomial with zeros of negative 2, negative 1, 0, and 2. So we can write our polynomial functions from the zeros of the function.